Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 2 Higher Tier from 2023. Question number 3 is on organic chemistry. Crude oil is a mixture of many different compounds. So we have crude oil. Give 2 reasons why crude oil is not a formulation. A formulation is a method of creating chemicals, substances or molecules specifically for a given reason. So crude oil was created naturally by nature millions of years ago. So it's not a formulation. So here's an answer that you can write. Crude oil, it is a mixture, but not a useful product. So formulation are useful products that we actually create using chemical reactions. So it is a mixture, but not a useful product, and not mixed in carefully measured quantities. Or you could say it is not designed for specific purpose and does not have the same composition all the time. What that means is, when we get crude oil from different parts of the world. Some of the biggest producers of crude oil is the Dubai, Saudi Arabia, Venezuela, Iran, and America. And the crude oil that we get from these different countries is actually different types, not identical. Question 3.2. Describe how crude oil is separated into fractions. Now, because it's a mixture, you'd use fractional distillation. By mentioning simply fractional distillation, you should get at least 1 mark. And the description of fractional distillation is what gets you the 4 marks. So we can describe this in 4 steps like this. Crude oil is heated to vaporize the hydrocarbons. Then the temperature of the column decreases from the bottom to the top. So the fractions or hydrocarbons condense at different heights in the column because they have different boiling points. Try and remember the fractional distillation column, what it looks like for when you're trying to separate out the mixtures, right? So it would be like this. Right? So you supply heat here, and the crude oil is actually heated and it vaporizes, and you'll have trays which collects the crude oil, right? And the gases are usually on the top, and low boiling point molecules are at the top, and very high boiling point fractions are collected at the bottom. Question 3.3. The fractions from crude oil contains alkanes. Explain why alkanes are cracked. Now, cracked or cracking is a process where you break long chain hydrocarbons into smaller chain hydrocarbons. So long chain hydrocarbons means carbons which have more than 10 to more than 20 carbon atoms, or possibly more than 12. So in a hydrocarbon chain, the carbon backbone, this is the carbon chain, and it's surrounded by hydrogen. So when you have more than 10 or 15 carbons, its boiling point is very high, which means that we don't generally find a lot of uses for it. So we can actually break them using catalysts. Explain how are alkanes cracked. Right? To make smaller hydrocarbon molecules, which are more, why are alkanes cracked? To make smaller hydrocarbon molecules, which are more useful as fuels or as starting materials. Cracking produces a mixture of products. So as you can see, the equation for cracking decane, C10H22, is C10H22 is broken down into C10 plus C10H20 plus hydrogen gas. Describe a test to identify the gas produced in the reaction. What is the test for hydrogen gas? You introduce a burning splint to the gas, collect the gas in a test tube, and you introduce a burning splint into the gas. So we can say test with a burning splint or a lit splint, not a glowing splint. Glowing splint is for oxygen. The result would be that it burns with a squeaky pop sound. Alkenes are produced in cracking. The general formula for the homologous series of alkenes is CnH2n. Which formula represents an alkene? So when we say CnH2n, let's say if n equals 2, then the formula will be C2H. 2n is 2 multiplied by the 2, that gives us 4. So C2H4. That would be this second one. Here you can see they have given 3 molecules with C2 and the third one is C3. So let's see if this follows the general formula as well. So if n equals 3 here, so C3H2 times 3 is going to be 6, right? So it's 8 here. Now the important thing about alkenes is that they always contain a double bond, carbon-carbon double bond. So here in the second one, it will be, let's draw it here, C, because there's only 2 carbon, so the double bond is between the carbons, and the hydrogen is formed like this, C2H4. That brings us to the end of question number 3, and I will see you in question number 4.